Hello, we are here for one more lesson of this T-FLEX analysis training course, and the topic for today will be the buckling analysis settings. Following the previous video where we've seen a couple of things, in particular the steps that we need to create the analysis for buckling. Now we will see a couple of parameters that are inside the dialog box where we enter to solve the calculation. So again, I've opened the same file as on the previous lesson. This is one example that comes with the software installation. We have the study already created, we have the boundary conditions already applied, so restraints and forces. Now we go to solve. And in this box, we have a couple of things that we need to check. The first one, and very important, has to do with this solve method. And in the solve method, we can apply different types of calculations. First one, this automatic assignment that evaluates the equations solution method. And we have a default in the system to 100,000 equations to use this automatic assignment. If the number is exceeded, then we go to other methods, in particular to the iterative method, which is faster. In this direct one, the system of equations is solved by Gauss method, which takes a lot of RAM compared with the other one with the iterative method. But the direct method is better for small problems, and when we are in presence of less than 100,000 degrees of freedom. This is a balance between complexity and time to calculate things. For last, this iterative method, so the system of equations is solved by these methods, and these do not require the complete inversion of the matrix, and this requires less RAM, so the calculation will be smaller and proportional to the number of natural vibration modes that we define on the calculation. These modes are inserted here. In our particular example, I have only one mode, but I can increase this value and create other modes for the calculation. And besides this, we can stabilize the system or not in case of need. And we can use also this setting here to activate the calculate using linear elements. And as the explanation appears here, it is recommended for calculations without the use of quantitative data for buckling. So it is an option of the user. This in fact facilitates a much faster calculation for having an estimation of the buckling mode amplitudes of the structure that we have in presence. So for easier and small element structures, we can leave these not activated. If we are in presence of big things, complex, maybe we can save some time using this method here. Then we have the thermal effects tab, and this is very similar to what we've seen for the statics before. So in here we consider the effects of temperature. So first we can activate this thermoelasticity. So in here it considers the influence of the heat stress to the rigidity of the construction. In here, we can consider also physical properties from the temperature, and considering this, we can define this value for a non-stress state, and we can consider also a uniform temperature, defined the value and the units. We've seen this already. And we can also use this preset temperature or use the results from a previous thermal study that was already in our machine. So after everything done and chosen, we need simply to go to the results tab, choose the type of calculations or results that we can obtain, and as we've seen already, just say OK, and it will move forward. In our particular case, probably we miss one of the conditions. I was not checking everything, so we get a little mistake here, but you understand the reason why. So basically, this is what we have to do to finish and to play with all the parameters for this buckling analysis.